In this video, I have a final example for you of ANOVA in action. You might recall from the previous video, when you run ANOVA, there's two possible outcomes. You can reject the null, in which case you have to follow up with post hoc testing if you want to identify where the specific differences are located. And you can fail to reject the null, in which case there is no post hoc testing because there's no need. So the null hypothesis for ANOVA, again, is that there is no significant difference between the means in question. And so if you fail to reject the null, that means that the evidence you have does not show that there is a significant difference. And so at that point, you're done. Now for this video here, we're going to use an example off of a mock exam. It's off of mock exam number 4. And as you can see, it shows the IMDb, which is Internet Movie Database, scores for a random selection of top grossing movies in 4 different categories. And as you can read down at the bottom there, we're asking effectively to determine whether or not these scores differ significantly. And so we're going to key this data into the calculator. You can download the mock exam from the course webpage and print it out for yourself. Or if you want, you could pause the video right now and you could just key this in. Obviously, you're going to be using a total of 4 lists. And on my calculator, I have the action movies in list 1. I have the comedies in list 2. I have the dramas in list 3. And I have the romance in list 4. And so as you can see, I've taken the time to key this in already. And so probably the next thing we'd want to do is we want to write down what we've got here. And then we can commence with the test. Before you perform ANOVA, there are some requirements that should be checked in order to make sure you don't come up against a garbage in, garbage out situation. And so you can read those on the screen in front of you right here. As you can see, first you have to have K, in this case 4, simple random samples, which we have. The data was randomly selected as it's stated in the problem. The random samples have to be independent of each other, which they are here as well, because again, they are randomly selected, and even though it's true they're all IMDb scores, they are randomly selected, and so there is no connection between the various samples in that way. And then probably for us the most salient requirements would be number 3 and number 4. So we want normally distributed populations, and we want them to have the same variance. Now before we run off to check these, let your eyes fall to the paragraph right below those requirements right there, and please read that carefully. Notice that it says that the methods are robust. So if we have small departures from normality, it's not going to be the end of the world. And likewise, the requirement of equal population variances is sort of relaxed a little bit when the samples are the same size, which they are here. And so if you go back and you look at the mock exam, you'll notice that we have 15 observations in each sample. And so as it says below, we can verify the requirements of normality by constructing normal probability plots. And so let's look very briefly on how we would check that. I'm not going to check every single one of them, but I'll show you a couple of them, and then I'll show you the summary of this. So you want to get out of here. Obviously, you have to have your data keyed in. And then you want to go up to the stat plot menu, and you're going to need 1 plot. The calculator, unfortunately, has only 3 plots, and so we can't do everything in one shot. We have to do it one by one because we have 4 data sets here for this problem. So in any case, you want to select that, and you have to turn the plot on, and then you have to select the correct type of plot. So a normal probability plot is the very last one, as you can see there. And you notice it's asking where's your data. And so we have a total of 4 different lists, and so we would check each of these individually. So for example, I have some data in list 1 that happens to be the action movies. And so if you wanted to verify that that's normally distributed, you could do as follows. You select that. You make sure all the other settings are what you want. And then you would quit this, and you would press Zoom 9. And that gives you an automatically fitted window that displays what it is that you're trying to display. Now I'm looking at this here and I'm thinking, well, it is a little bit curvy. There is a little bit of a gap there in the middle. And I concede, it is very difficult to visualize this. It's not as easy, let's say, instead, as using SPSS or something that puts on, the 95% confidence bands and all of that. but it looks more or less straight, and it isn't real gappy. And if you wanted to sort of verify that what you're seeing is what you want to see, another way you could look at this would be as follows. You go back to your stat plot, and you want to change the plot type. So the one that's flashing right now is the one that gives you a box plot plus a check for outliers. And so since both of those things would be of interest when you're checking normality, this is not a bad insurance policy. And so again, once you've selected that and everything else looks correct, you would quit this. You can zoom 9 it, and there's your box plot for action movies. And so even though it's not exactly what we would want, with regard to a normal distribution, you can see that the median is skewed somewhat to the left there. It's normal enough for us, and so I would be satisfied with this particular data set. Now, if you look at the summary of all the data sets, here's the plots that you're going to see. So action movies is at the top. We just saw that. And then we have comedy and drama. And comedy has an outlier, as you can see. So you have this one data point which is out in the middle of nowhere. It corresponds to the data value of 4.2. You can find that by tracing it on the calculator. And is that a deal breaker? Well, as you read in the text, small departures from normality are acceptable. And so when I'm looking at that data set, yeah, I have an outlier, but I also have a nice looking box plot, and the rest of the normal plot looks pretty good for that one. As far as the rest, I think that we're okay for this particular example. So I would say that even though it's not perfect, it's okay for our purposes. And keep in mind also the context here. We're not testing the safety of a drug or the efficacy of a cancer treatment or something like that. We're looking at movie scores. So small departures are going to be acceptable. And so at that point, we're satisfied that we've checked the conditions, and we would be ready to run the test then. Now let's make sure we have everything we want here. What do we need to write down for this particular test? So what are we testing here? Well, you can see it written on the screen in front of you. The null hypothesis is always a claim of equality, and we are assuming that none of the means differ significantly. We always assume that is true as part of the process. And we're putting that up against the alternative hypothesis that says that at least one of the means differs significantly. And so we're ready to run the test at this point. Let's do so. So go to my stat menu, and I'll go to the test submenu, and we're looking for ANOVA. And we have our information in list 1 through 4. And so we run the test, and here's our results. So if you got the same test statistic on your calculator, then that shows you keyed everything in and you ran the test correctly. And as far as the salient details on this screen here, we would want the test statistic and the p-value, and we probably should jot those down. Let's do so. So I have my test statistic recorded, 2.229, and I have my p-value recorded, 0.095. Now notice, so far we haven't seen a level of significance provided in this problem, and that's not an accident. We don't have to have a level of significance provided, and in fact, it's not considered the appropriate way to go about a test these days. The idea is when you supply the p-value, you're effectively allowing the reader to decide for themselves whether to reject the null or not. Now in this particular case, the p-value is rather large. It's 0.095. It's very close to 0.1, which would be 1 out of 10. And so for that reason, I mean, it is true that we're testing movie scores here. It's not some kind of a hugely important thing. It's not like we're testing the safety of a drug, or we're testing something that's going to put someone in jail or something like that. We're testing movie scores, right? And so you will see some tests that are run at the alpha as 0.1 level of significance, and if that were the case here, we would be rejecting the null because the p-value is less. But generally speaking, for a statistically literate reader, when they're seeing a p-value this large, they're thinking, well, that's a large p-value, and so I'm probably not going to reject the null because the evidence doesn't support the alternative hypothesis. And so let's take a look at what we're being asked here on the mock exam, and we'll see how we can respond to those questions. So the first of these questions here is number 39, and it's asking, what are we testing effectively? And so if you recall, for the ANOVA process, the null hypothesis is always a claim of equality, and the alternative hypothesis is always a claim that there is at least one mean differing. And so that would be choice A in this particular case. For question 40, it's asking what process would you be using? And I mean, you just saw us use ANOVA, so the answer to that question is rather obvious. But I'll tell you directly, it is very surprising sometimes that people will look at a problem on an exam, and when it's stripped of context, in other words, when it's not appearing in a particular section of the text or something like that, they don't know what process to use. And so we do want to know that you know what's appropriate. And then finally, the last question would be number 41, and it's visible just down at the bottom of the screen there. I can't scroll too far, it's going to hop off the page. It says, using the data given above, if you use the appropriate test, what's your test statistic? And so as you saw, it would be choice D in this case. It's 2.229. What else do we have here? Well, we have question 42, and it's saying, on the basis of the p-value from the test, if you round it to 3 places, which we did, it was 0.095. What is the smallest value of alpha at which we could reject the null? So if you remember, when you are doing a p-value based version of a test, when the p-value is less than alpha, you reject the null. And so in this case, it would be choice D. You have to be larger than 0.095. And then finally, regarding question 43, it says, what is your conclusion in practical terms? So we were saying, well, we're not going to reject the null because the p-value is so large. And so what that means is what you see in choice C there. It says the evidence we have does not support the claim that at least one of the means differs significantly. And so hopefully that will be helpful. Let's jot down our conclusion really fast, and then we'll be done. So as far as my conclusion, I'm stating here at the bottom that we can't reject the null because the p-value is large. I'm sorry that my handwriting is so awful. It's down at the bottom of my screen. It's very hard to write there. Anyway, we already stated the practical conclusion on the mock exam there. So hope this has been helpful, and if you have any questions, feel free to drop me a line.